Hi, this is Keith from Pharmacy-Tech-Study.com, and this is another video for the dilution math page, and we're still going to address the same question we did in the last video that's above this one on the page, and that is the question: the pharmacist hands you a 1.5 liter bottle of a 20% solution and asks that you mix it with sterile water enough to make as much 12% solution as possible. How much water will you use? Now, in the method above, I showed you how to use proportions math, and it got a little bit complicated and a little wordy and a lot of ink on the board. And so there's a couple other ways that you can do it. And the first way is you can actually use an alligation. Although until you're really good at allegations and you really have your mind wrapped around them, I wouldn't suggest using it, but just to show you how that does work. So you have a 20% solution, which is your higher strength, and then you have a 0% solution, which is your water, and then you have a 12% solution, which is your desired concentration, so that'll go in the middle of our tic-tac-toe grid. Okay, so going ahead and diagonally figuring out the difference, we have 12 here, and then 8 this way. So we have a ratio of 12 to 8, and so each of these is divisible by 4, and so I'm going to go ahead and do that, and what I come up with is 3 parts and 2 parts. That's my ratio here, which could also look like this. Now I know that I have 1.5 liters of the 20% solution, so now I could just do a proportion math this way. I could either do 1.5 or 1500 milliliters. Either way it's going to work. And then I could solve for x. So if we did that and we did our proportions math, x would equal 1, or in this case 1 liter. And you could also do the same thing down here, figuring that if you have 3 parts of something that added up to 1.5 liters, 2 parts of that same ratio would equal 2/3 of that, which 2/3 of 1/5 is just 1. So the correct answer is 1 liter, or 1,000 milliliters. So that's the alligation way to do it. And if that works for you, that's actually a pretty quick and efficient way to do it. I didn't even have to write all this stuff. A lot of this stuff you would have been able to just do in your head. But so there's that way, and then there is the algebra way, and let's talk about that now. So the equation that you would write in an algebra method would be 1500 milliliters of 20% plus, we'll say x, let's put everything in parentheses so we know what we're going to multiply versus add, of 0.00 equals 12%, oops, which is 0.12, 1500 plus x. Now I wrote the 1.5 liters as 1500 milliliters because looking at the answers, the multiple choice answers, that's what they're in, is milliliters. So it's going to be quicker when I'm done just to have it in milliliters. So anyway, doing the math, 15 times 0.20 is 300. X times 0.00 equals 0. Okay, and then going this way, 1500 times 0.12 equals 180. Check the camera here, there we go. And then x times 0.12 equals 0.12x. Okay, so we'll keep doing our math here. Actually, what we want to do is isolate this x. So the first step we're going to do is subtract 180 from both sides. And that'll get us down to our 0.12x. So when we did that, what we got over here was 120. So now we have 0.12x equals 120. So in order to isolate the x, we want to divide each side by 0.12, and that cancels there. 0.12, and 0.12 goes into 120 1,000 times. Alright, so x equals 1,000, and what that means is 1,000 milliliters is our unknown quantity up here. So that is the algebra way to do it. So in this video I showed you the alligation method and then the algebra method, and actually these two are easier, I think, than the proportions math video that's higher up on the page. So 1,000 milliliters in the question going back, that is answer C.